Right. So, friends, we will be discussing. We will try to define what is machine learning today. Right. I'll share my screen. A quick recap of what we have discussed yesterday. Right. Yesterday we have seen introduction part. So we have seen how actually this concept of machine learning has evolved, and what is the purpose of machine learning. Right. So basically, problems are of two types: deterministic and non-deterministic. Till now, whatever problems we have solved using other programming languages like C, C++, Java, they all come under deterministic problems. So deterministic problems are the problems for which there exists a systematic and standard procedure. Non-deterministic problems, they don't have a fixed solution. So for non-deterministic problems, we can't write any standard algorithm or procedure to solve them, right? So for example, if you take a photograph and you want to check whether there is a cat in it or not, so how do you write an algorithm you to check whether a given photograph or a image contains a cat or not? There are different types of cats, different shapes, different positions. This we have discussed yesterday, right? So for such kind of non-deterministic problems, we cannot write algorithm. So when we cannot write algorithm, how do we solve non-deterministic problems? So this was a big challenge some 25, 30 years back. So when people thought these non-deterministic problems, which are very tough for computer to solve, on the other hand, they are very easy for a human being, right? You give a album or you give a photograph to a person and ask him whether there is a cat in it or not. Even a small kid can tell there exists a cat in an image or not. So it has been observed that non-deterministic problems are very difficult for computers to solve, whereas most of the non-deterministic problems are very easy for human being, right? So with our natural intelligence, we can say by looking at the photo, we can say there is a cat in it, there is a dog in it, there is no cat, there is no dog. Like that, easily we are able to classify, easily we are able to identify. So identification, classification, these kind of problems are very easy for us to solve, whereas for computer it is very difficult. So people thought, why can't we impart this natural intelligence of humans into computers? When people thought this, artificial intelligence word was defined. So the word artificial intelligence says that if we can impart the natural intelligence of humans into computers, then computers can also solve these non-deterministic problems easily. Computers can also make decisions like humans. So this with this idea, a new domain or a new subject came into existence called as artificial intelligence. Right. This is very important as discussed yesterday in our previous class. What is machine learning, right? So if you look at this diagram, machine learning is one form of artificial intelligence. People are still waiting. So machine learning is one form of artificial intelligence, right? This diagram is very important, friends. Right, down the line for another 10 years, 15 years, you will find career opportunities in this area. So this is very important subject, very important course, right? So artificial intelligence is a very broad term. So how do you impart natural intelligence of humans into computers, that is AI, right? Artificial intelligence, and how we achieve artificial intelligence, how do we implement it? There are so many methods, and machine learning is one form of artificial intelligence. Again, under machine learning, we have concepts like neural networks and deep neural networks. They are again one form of machine learning, right? So if you observe the subset, deep learning is part of neural network is part of machine learning. machine learning is part of AI, right? So this is one more important thing which we have seen, and we try to understand this particular block diagram in detail today with another example, right? So if you observe traditional programming, in traditional programming we give data and program as input to the computer, and computer generates the output. Suppose you want to find roots of quadratic equation, you will give ABC values as input, you will give the code to find roots of quadratic equation as the program, and computer will calculate the roots and it will generate the output. Whereas in machine learning it is totally different. We give data and output to computer, computer should generate the program. Here this output of machine learning, this program is instead called as machine learning model, right? So many people will be confused by looking at this diagram and they'll say, sir, what is this? How can you feed output? How output can become input to computer? How do you feed output as input to computer, right? So this block diagram itself will be confusing for many people, but we need to understand this clearly. So for that we will take another example and we'll try to understand this, right? And yesterday, if you remember, I have also discussed the applications of machine learning. Machine learning is applied almost in every organization, every business, right? Every domain. You go to manufacturing industry, you see machine learning. E-commerce, machine learning. Banking, insurance, healthcare, right? Automobile sector. Everywhere you find machine learning, right? So we will quickly discuss. So this was a quick recap of what we have seen yesterday, right? Now what we will do is today we will be trying to define certain things, right? Yeah. So this is unit 1, and whatever material, whatever concepts we are discussing, please try to understand the concepts. Don't note down anything not required, right? Whatever material I'm using here, whatever I'm preparing, it will be shared. At the end of every unit, I will give you this material, right? So please don't worry and do not waste time in writing some points, all those things not required, right? So friends, each and every point, whatever I'm writing or I'm showing in this material, each and every point is very, very important, right? So today's class is like a foundational class. So please try to understand each and every concept. And if you don't understand, please let me know so that we should not go to next topic with some doubts or confusions in the present topic, right? So the field of machine learning is concerned with the question of how to construct computer programs that automatically improve with experience. This is an important point, my dear friends. What is what is this field called as machine learning? It deals with what? So machine learning is a field, and it is concerned with the question, and it is concerned with the question of how to construct computer programs that automatically improve with experience, right? So please try to understand this word, right? So no issue. The field of machine learning is concerned with the question of how to construct computer programs that automatically improve with experience. So, what do you mean by experience? From where computers get experience, from where computer programs will get experience? All these things we need to understand. Each and every word is important, because nowadays each and every person, wherever you go, people say, I'm doing a project in machine learning, I'm working in machine learning, ml, right? So that's the reason fundamentals of ml are very important for everyone. So the field of machine learning, it deals with how to construct computer programs that automatically improve with experience, right? We will come back, we will try to understand this statement today with one beautiful example, right? Now, another important statement: machine learning is a multidisciplinary subject. Machine learning is a multidisciplinary subject which draws on the concepts from many fields, including statistics, AI, philosophy, control theory, biology, right? These there are so many other fields, but more prominently these are the five different fields or concepts which you can say, right? ML is based on all these five things. Even biology plays an important role, right? When we discuss neural networks, you will understand why biology is also important in machine learning, right? So slowly, one by one, like the stats, AI, philosophy, control theory, over a period of time, when we discuss unit 3, unit 4, and unit 5, at the end of the course you will definitely realize, like multi machine learning is a multidisciplinary subject, right? So machine learning theory attempts to answer two important questions. So if someone says why machine learning, right? So machine learning theory attempts to answer two important questions. They are: how does learning performance vary with number of training examples presented? How does learning performance vary with number of training examples presented? Which learning algorithms are more appropriate for variety of learning tasks? Friends, these two statements you will not understand as of now, right? Because you don't know the meaning of learning. First of all, what is learning? You don't know, right? Learning means not the way we have learned our school education, 10th, intermediate. Not that learning. We are talking about machine learning, how machines will learn, right? So many questions will come: how machines will learn, right? Who will teach, right? How they will learn. So when you understand the meaning of learning, when you understand the meaning of learning, then only you can come back and you can think of these two statements. So when you understand the meaning of learning, then only you can come back and you can think of these two statements. So definitely we will come back. Definitely we will come back to these two statements. Now we will define machine learning, or you can simply say we are going to define something called as learning, right? So definition of learning. So what do you mean by learning? This definition is very, very important. Followed by this definition, we will see an example. Followed by this definition, we will see an example. Look at this one. A computer program, a computer program is set to learn, a computer program is set to learn from experience E. So here experience is represented as E. Don't worry what is experience, from where this experience came, all those things. When I show you the example, you will understand all these things. People are waiting. Right? So a computer program is set to learn from experience E with respect to some class of tasks, with respect to some class of tasks T, and performance measure P, and performance measure P, right? It performance measure P. Its performance at a task T. What is performance measure? Means it is its performance task in its performance measure in task T as measured by P improves over experience, improves with the experience, right? So a computer program is set to learn from experience with respect to some tasks T, and P is the performance measure, right? So there are three important parameters. One is called as a task. The computer program will perform the task based on the experience, right? and performance is measured, or you can say performance will improve. P will improve based on, so performance will improve based on experience, right? If I become more and more experienced, my performance will improve, or my performance should improve. So what do we mean by performance, right? What is this task? What is experience? Entire definition, entire definition you will understand completely when you see this example which I am going to show you now. So a computer program is set to learn from experience with respect to some class of T tasks and performance measure P. Performance improves with experience. So this is what is the definition of machine learning, or you can say definition of learning, right? Obviously, you will not understand this particular definition until unless you see a simple, meaningful example, right? Friends, look at this example. Please look at this example which I am showing. Please observe this. So just imagine this is heights, and this is weights, right? So if height is 4 feet, weight must be 52 kgs, 4.2 56, 4.5 57, 4.11 60, 5.1 61 kgs, 5.2 64 kgs, 5.4 66, 5.5 68, 6 feet 75, 6.2 77, right? So please observe this. These are heights and weights. Heights and weights. Fine, let us assume for a moment, let us assume these are correct values. Let us assume I got this information from a doctor, like what should be the valid height. If height is 4, weight should be 52. Let us say I got this data from the doctor, and let us assume they are correct. Now what do you mean by learning means? I want to create a computer program, right? Please try to understand the question. I want to create a computer program which should tell me, suppose if I ask, if the height is 6.7 feet, then what should be the weight? So if I give the height as input, my computer program should tell me, okay, if height is 6.7 feet, weight should be 86 kgs. Like that, I want a computer program. If I ask my computer program, if the height is 7 feet, what should be the weight? 78. Like that, I want my computer program to predict certain things, right? So now, how is it possible? Simple logic. Now, how do you write such computer program, which is nothing but a machine learning model? Such computer programs are called as machine learning models. Machine learning model, right? So now look at this one. What I am trying to do is, there are heights and weights, no? What I am trying to do is, I am trying to put them in a chart. See here. Please look at this. Same thing, whatever was there in Excel, I am trying to put it in the form of a chart. Right now, if the height is 4, weight should be 52. If the height is 4.2, weight should be 56. If the height is 4.5, weight should be 57. 4.11, weight should be 60, like that. Now if you observe, when I change the value of one variable, now there are two variables, my dear friends. One is height, another one is weight. One is height, another one is weight. When I change one variable h, right? Second variable w will also change. Second variable w will also change, right? Now don't you find there is a dependency, or there is a what we say, some kind of association between H and W. Will you accept that if H is changing, W has to change? Will you accept that when height is 4, weight should be 52? When H became 4.2, weight is 56. When H became 4.5, weight is 57. There is a relationship between these two variables. Do you accept this point? Please tell me. Please respond in the chat box. Please respond. Height and weight example we have seen. If one variable called as height, if I make some changes in height, obviously the change in the weight is noticed. The weight should also change, right? So is there any relationship between height and weight? Please let me know. Please respond in the chat box. Please type. What happened? Nobody is responding. Yes, okay. Only one student has responded. Yes, sir. Okay, so when there is a height, when height is changing, the weight is also changing, right? Now, can I say weight depends on height? Can I say like this? Weight depends on height. Can I say like this? Please respond. Weight depends on height. Okay, we can define. Right. Now, one more important point. This is very, very important session, friends. I want everyone to understand this. So, weight depends on height. So, I'll call weight is dependent variable. I call weight as a dependent variable. Height is independent variable. These two words are very, very important, right? Lot of mathematics will come in machine learning, especially related to statistics, right? Whatever important words are coming, I will highlight them. I want you to understand them clearly. If not, please let me know, right? So since weight depends on the height, weight is the dependent variable, height is independent variable, right? Weight is dependent variable, height is independent variable. Now, please look at this one. Now, when height is 4, weight is 52. Okay, fine. Now, when I made height as 4.2, means how much variation was made in height and how much variation was noticed in weight, right? So can we measure this proportion of change? See, a height was made 4.2. How much change I made in height? How much changes occurred in weight? Can we measure this? Can we measure this? How much changes I made in height? We now accept that when height is changing, weight will change definitely. So how much change was made in height and how much it affected weight? If I change height, how much effect is there on weight? Can we study this? Can we study this? Can we study this? Please observe this. Y is equal to mx plus c. Y is equal to mx plus c. Do you remember this? Y equal to mx plus c. Y equal to mx plus c. Y is equal to mx plus c. Sorry, mx plus c. Y is equal to mx plus c. Right? Do you remember this? We have studied this in our basic maths of 10th standard or intermediate. We have studied this. Y is equal to mx plus c. Y is equal to mx plus c. In this is equation of a line. Y equal to mx plus c is equation of a line. Now, friends, I please observe this. Right here, this x and this height and weight can be considered as this height will become x, y will become weight will become y, because weight depends on height. Now this m is nothing but slope. M is nothing but slope. You might have studied y equal to mx plus c, that slope determines the amount of change that is occurring whenever we are making some changes in height, right? So slope determines this. I will change for your convenience. What I'll do is I'll change the design. See here, something like this. So when height is 4, weight is 52. When height is 4.2, weight is 56. When height is 4.5, weight is 57. So how much change is there? How much variation is there? That is noticed or studied using slope. M defines, small m defines that particular change, right? So what we are doing in this machine learning subject, or what we are doing in this ml part, is very simple, friends. This is only one example. This is used only to explain you what is meaning of learning. So what we will do is in machine learning. So let me explain this example in detail. So now you understood the problem statement, right? So heights and weights we have, and we have seen this graph also. Now what we will do is we will write a program. In that program, we will apply y equal to mx plus c, right? And we will run this on all these 10 inputs. 10 heights I have, 10 weights I have. So for these 10 heights and weights, I will try to apply y equal to mx plus c, and I'll try to study how this m is behaving, or what is the value of m, how m is changing. I will try to study that, right? Now what is the importance of this one is, if I know this m part, now what I'll do is in future, when you ask me if height is a 6.11, what is the weight? When height is a 6.11, what is the weight? Now what I will do, I will apply y equal to mx plus c. C is a constant. M value I know. From where I got m? Because of all these values of y, both x and y I had, and from this data I calculated m. So I will apply my m value here. X is 6.11, some constant will be there c, then I will get value of y. So if you ask me what should be the weight for 6.11 feet, then I will apply y equal to mx plus c, and I may say, okay, it should be somewhere around 87 kgs. So like that, I am trying to make my program to learn something. So here, what do you mean by learning, or how computer program is learning means very simple, friends. We are going to apply some functions. So already I will take some data, existing data. If you observe here, we have data as well as output also. If height is 4, what is the weight? Weight is 52. Already I know. That's the reason. That's the reason. See here. In this block diagram, I am giving data as well as some outputs also. So for my 10 examples, along with the data, I also have the output. For height, what should be the weight? For 4.2, what should be the weight? I have both. Now, by applying this data using this function, I will use this function and I'll apply y and x values will be replaced with all these 10 combinations. Then I will study, or I will come to know what is the slope. Once the slope is known, now if you ask me for 6.11 feet, what should be the weight? 6.11 will become x. Slope I already have calculated, so I will tell you what is the y value, or what should be the ideal weight. So this is called as learning. So don't get surprised or confused like how computers can learn. Computers cannot learn because they are not human beings, but we are making computers to learn. We are making computers to learn. So this data which I am giving as input, which I am using to train my function. So this is called as a training data, right? And this is the function which is going to calculate the value of m, and this function will help me in predicting the weight for a given height value. So if I create a machine learning model, my model will predict the weight for a given height. How my model can predict the weight for a given height? Because my model has lot of knowledge I have given to my model. This is the knowledge. So based on its knowledge, my model can predict the weight for a given height. Till this point, is it clear? Because next topic is very important, because from this topic lot of questions will come. Till this point, is it clear to everyone? Height and weight example. Please respond in the chat box. Please respond in the chat box. Is it clear till now? Is it clear? Yes. So now there are so many questions. Questions are, sir, for 6.11 feet, your machine learning model says weight should be 87. Now, what is the guarantee that your machine learning model, the answer generated by your model is correct? What is the guarantee? This is the question, right? So, friends, very important point. The machine learning models, whatever output generated or results generated by machine learning models, they need not be 100% accurate. They need not be 100% accurate, and it will be very difficult to get 100% accuracy also. It is not 100% accuracy is not possible every time, but anything between 80 to 90% of performance measure, if the performance is 80 to 85% accurate, then the model is considered to be a good machine learning model, right? 100% ideally it's not possible to get 100% accuracy, but somewhere around above 95, 97 is considered to be great. Anything above 80, 85 is a good machine learning model. So what I am trying to say is this 87 may not be the correct answer, but at least suppose let us assume the answer generated by my program is 85, but originally the ideal weight should be 86.5. Let us say as per doctors 16.11 6.11 feet means it should be weight should be 86.5. My program has calculated 87. So this is called as error, the difference between expected output and actual output. This difference is very very less, so it's not a problem, right? Now how do I improve my model? Right, it is calculating height, weight for a given height, it's okay, but how do I measure the performance? Is it correct every time? Is it giving me correct answer? If not correct, then at least to what extent it is giving me a nearest value? Like that, so many questions will come. So the very first thing what I will do is I have to improve the training. So this data which I have given, 10 heights and 10 weights, this is not sufficient. So we should give more amount of training. You increase the training, you increase the training experience, you increase the training experience, your model's performance will improve, right? Of course there is a case where excess training or too much of training will also impact negatively in the performance of the model, that we will see in an appropriate time. As of now, if the training is very very less, the model's accuracy will be less. So increase in training will definitely improves the performance. So training gives experience to the model, right? So my computer program has got 10 heights and 10 weights, means it has a knowledge of 10 heights and 10 weights, based on which it is trying to predict weight for a given height. Instead of 10, if I give 20 inputs, let us say 3.5, what should be the weight? Similarly 4.9, what should be the weight? Something like that. If I give 20 training inputs, heights and weights, obviously more amount of knowledge I am giving, so more will be the more experience my model is going to get, and model's performance will improve with experience. So how much training you are giving is very very important, right? So coming back to the definition now, coming back to the definition, a computer program is set to learn from experience. So what do you mean by experience? Now you understood the meaning of experience, right? So this kind of data and possible outputs, both we will give to a function, some mathematical function, right? Our model is nothing but, our machine learning model is nothing but it is based on some mathematical function, right? In this example, it is y equal to mx plus c. So this mathematical function will get the training from training data, which contains training inputs and possible outputs. So this is called as training. So when a model gets trained, it will get the experience, it will get the knowledge. So what do you mean by experience? I hope you understood, right, from that heights and weights example. So a computer program is set to learn from experience. So now I don't think you have any confusion how computers will learn. Computers cannot learn, they are not human beings. We will write programs such that computers will learn from experience. So a computer program is set to learn from experience E with respect to some task. So what was the task here? Task was to predict the weight. What is the task? Task is to predict the weight. For a given height, I need to predict the appropriate weight. So task is prediction. So task is prediction. E means experience, and performance measure. Performance measure means, let us say for 6.11 feet, ideally the weight should be 86.5, but my program told 87, right? So it is almost close to the correct answer. So to some extent I can accept this. So I can say it is performing well. Of course, there are so many other techniques of performance measurement. We will discuss them in our future units. But what do you mean by performance? How accurate is your machine learning model? What is performance? How accurate is your machine learning model? So this is called as performance. So three words everyone should understand, otherwise we can't move forward in this subject. So these three words are learning experience, which is possible by training. So you train the model, right? Model is nothing but the computer program which we are going to write, right? So we train the model, right? And model gets the experience to perform a task, right? Now task can be identifying something, task can be predicting something, task can be classifying something, right? Given an image, it should tell whether the image contains cat or not. It's a classification problem, right? So suppose in a traffic there are so many vehicles in the signal, I need to identify an ambulance. If at all there is an ambulance, I should automatically convert red signal into green signal so that I can help ambulance. I don't want ambulance to struck in the signal. So I need to identify from a given set of images from the traffic signal, I need to identify whether there exists an ambulance or not. So like that, identification problem, classification problem, prediction problems, so many variety of problems can be solved efficiently using machine learning. So E means experience, T means the actual task which we want to do, and P is the performance measure, right? So what do you mean? What is the definition of learning? A computer program is said to learn from experience with respect to some class of tasks, T, and performance measure, P. So P improves with experience. So this is what is the technical textbook definition of machine learning. Right, friends? Till this point, is it clear to everyone? Please let me know. Please let me know in the chat box. Till this point, is it clear to everyone? I want everyone to respond because I need to understand how do I move forward. Please respond. We thought of discussing well posed problems. What is a well posed problem? We will just define this word well posed problems and we will wind up. So, till this point, I think things are clear to everyone. Please respond. Please respond in the chat box. Right. So, friends, well posed learning problem. If you see your syllabus, this will be the first topic. Well posed learning problems. What do you mean by well posed learning problems? Learning problems are said to be well posed if there exists a unique solution, if there exists a unique solution for the problem, and solution behavior changes with the initial conditions. Solution behavior changes with the initial conditions, right? So what this initial condition in our problem of y equal to mx plus c heights and weights example, we did not find any initial condition, but in future when we will discuss neural networks, Then we will come across something called as weights, adjusting the weight. What is not this height weight example? We have a technical term called as weights. When we study neural networks, you will come across this word, initial conditions. So learning problems are said to be well posed if there exists a unique solution for the problem, and solutions behavior changes continuously with initial conditions. So this is what is the meaning of well posed problems, right? So we will discuss couple of examples under well posed problems, right? It can be an driverless car, or it can be house price prediction. See, whatever examples which we are going to discuss as part of this subject, most of them can be converted into projects, right? That is the greatness of this subject. If you understand the concepts, your project work will also be completed. If you can add a little bit of what do you say, if you can extend it, it will become your project also. So some of the problems which we are going to study under well posed learning problems is driverless car, house price prediction, right? And even uh, robot behavior, right? Or you can take any other problem, any game, etc. So couple of examples of well posed problems we will discuss in our next class. Then this is an important, very important thing, my dear friends. How do you design a learning system? Means what are the design issues that can come in a learning system? Design issues in a learning system, right? This is an expected question also in your examination, both mid exam and external exam. Design issues in a learning system. How do you design a learning system, right? This is very important topic. This we will discuss in our next class. So today we have I have tried to explain you the meaning of machine learning and the definition of learning. What is learning and what do you mean by a well posed learning problems, right? So in the next class we will discuss couple of well posed learning problems, and we will identify certain issues. Then we will talk about how do we design a learning system. This is very important topic which will be discussed in the next class. So today's introduction and definition of machine learning, is it clear to everyone? Kindly respond in the chat box. Please respond in the chat box before we wind up. What is a well posed problem? Please let me know whether today's session everyone understood today's concepts or not, because it's very important. Definition part we have seen, important terminology like training, experience, then learning, performance. These are the important words which we have discussed today, right? Please let me know, is it clear to everyone? Right. So okay, friends, we will meet on Monday and we will be discussing designing a learning system. Right. So, thank you. Thank you very much.